Rational Expressions Lesson 2. We're going to look at a couple of different examples today. So remember that to start, we want to factor anything that's factorable. So in the top, I have 1 minus t. In the bottom is a difference of squares, so it results in two sets of brackets. First one is the square root of t squared, so t and t. Then the square root of 1, which is 1 and 1. 1 becomes positive and one bracket becomes negative. You'll notice that the numerator and one of the factors in our denominator are very similar. However, the order of those terms is not the same. So what we're going to do is we are going to take out a factor of -1 from the top. And this is a trick that often comes up. If I take out a factor of -1, I end up with -1 plus t. The bottom stays the same. It should be -1. I can then rearrange the order of my numerator. So it's -1 times t subtract 1 all over t plus 1, t minus 1. I now have two identical factors that will cancel out. And my final answer becomes -1 in the top over t plus 1 in the bottom. And so that's a trick to be watching for as you go through these questions. Let's look at one more. In the top, I can take out a factor of 2. Leaves me with 3 minus m. The bottom is a difference of squares. And so we get m minus 3, m plus 3. Again, we have that similar pattern of this factor and this factor looking very, very much alike. So let's take out a factor of -1. So it actually becomes -2, and in the top, it then becomes -3 plus m. Rewriting my denominator the same as it was in the step before. I can rearrange the order of the factors in the top, so -2 times m minus 3. I now have a common factor in the numerator and the denominator of m minus 3. So those two cancel, and I'm left with -2 in the top, and in the bottom, m plus 3. The next case that we have is where we have two different variables in our numerator and denominator. So let's start by factoring both. So if I'm factoring the top is still a difference of squares because 16x squared and 9y squared are perfect squares. So that means it's going to factor into two equal factors, where one becomes 4x minus 3y and the other one 4x plus 3y. In the bottom, I can take out a common factor of 2, leaves me 4x minus 3y. I need to remember to look at my restrictions. So what values can x and y not be? Means that I cannot end up with 0 in the bottom. So that means that 3x minus 3y cannot be equal to 0. And so when we're doing restrictions in this, we try and write one variable in terms of the other. So I'm going to try and isolate x. I'm going to add 3y to both sides. I end up with 4x cannot equal 3y. Divide both sides by 4, and x cannot equal 3/4 y. So this gives us a variety of different combinations of x and y that we can't have. For instance, one that we can't have is we cannot have the point where x is 3/4 and y is 1. If we do that and substituted that into x and y, we would find that that is one of the restrictions we can't have. It would also give us 0 if we substituted into our denominator of our expression. So there's our restrictions. If we are now finishing simplifying, I have a factor of 4x minus 3 in the top and in the bottom, leaving me with 4x plus 3y in the top over 2 in the bottom.